Study Section 4, Data Resource Management. Introduction. This study session will acquaint you with the need for database resource management, DRM. It will also expose you to the various types of DRM. Learning outcomes. When you have studied this session, you should be able to explain the need for data resource management, explain different types of database used in information system, use warehouse of databases. Rationale for database resource management. How important is data to organizations? Data are vital organizational resource that needs to be managed like other important business assets. Today's business enterprises cannot survive or succeed without quality data about their internal operations and external environment, and that is why organizations and their managers need to practice data resource management, a managerial activity that applies information systems technologies like database management, data warehousing, and other data management tools to the task of managing an organization's data resources to meet the information needs of their business stakeholders. This lesson shows the managerial implications of using data resource management technologies and methods to manage an organization's data assets to meet business information requirements. Types of databases. Continued development in information technology and its business applications have resulted in the evolution of several major types of databases. Let's take a brief look at some of them now. 1. Operational databases. Operational databases store detailed data needed to support the business processes and operations of a company. They are also called subject area databases, SADB, transaction databases, and production databases. Examples are a customer database, human resource database, inventory database, and other databases containing data generated by business operations. To be specific, a human resource database will include data identifying each employee and his or her time worked, compensation, benefit, performance appraisals, training and development status, and other related human resource data. Distributed databases. Many organizations replicate and distribute copies or parts of databases to network servers at a variety of sites. These distributed databases can reside on network servers on the World Wide Web, on corporate intranet or extranet, or on other company networks. Distributed databases may be copies of operational or analytical databases, hypermedia or discussion databases, or any other type of database. Replication and distribution of databases improve database performance at end-user websites. Ensuring that the data in an organization's distributed databases are consistently and concurrently updated is a major challenge of distributed database management. Distributed databases have both advantages and disadvantages. One primary advantage of a distributed database lies with the protection of valuable data. If all of an organization's data reside in a single physical location, any catastrophic event like fire or damage to the media holding the data would result in an equally catastrophic loss of use of that data. By having databases distributed in multiple locations, the negative impact of such an event can be minimized. Another advantage of distributed databases is found in their storage requirements. Often, a large database system may be distributed into smaller databases based on some logical relationship between the data and the location. For example, a company with several branch operations may distribute its data so that each branch operation location is also the location of its branch database. Because multiple databases in a distributed system can be joined together, each location has control of its local data while all other locations can access any database in the company if so desired. Distributed databases are not without some disadvantages, however. The primary disadvantage is in the maintenance of data accuracy. If a company distributes its database to multiple locations, any change to the data in one location must somehow be updated in all other locations. This updating can be accomplished in one of two ways: replication or duplication. Updating a distributed database using replication involves using a specialized software application that looks at each distributed database and then finds the changes made to it. Once these changes have been identified, the replication process makes all of the distributed databases look the same by making the appropriate changes to each one. The replication process is very complex and, depending on the number and size of the distributed databases, can consume a lot of time and computer resources. The duplication process, in contrast, is much less complicated. It basically identifies one database as a master and then duplicates that database at a prescribed time after hours so that each distributed location has the same data. One drawback to the duplication process is that no changes can ever be made to any database other than the master to avoid having local changes overwritten during the duplication process. Nonetheless, properly used, duplication and replication can keep all distributed locations current with the latest data. External databases. Access to a wealth of information from external databases is available for a fee from commercial online services and with or without charge from many sources on the World Wide Web. Websites provide an endless variety of hyperlinked pages of multimedia documents in hypermedia databases to be accessed. Data are available in the form of statistics on economic and demographic activity from statistical databanks, or you can view or download abstract or complete copies of hundreds of newspapers, magazines, newsletters, research papers, and other published material and periodicals from bibliographic and full-text databases. Whenever you use a search engine like Google or Yahoo to look up something on the internet, you are using an external database, a very, very large one. Hypermedia databases. The rapid growth of websites on the internet and corporate intranet and extranet has dramatically increased the use of databases of hypertext and hypermedia documents. A website stores such information in a hypermedia database consisting of hyperlinked pages of multimedia, text, graphic, and photographic images, video clips, audio segments, and so on. That is, from a database management point of view, the set of interconnected multimedia pages on a website is a database of interrelated hypermedia page elements rather than interrelated data records. Figure 4.2 shows how you might use a web browser on your client PC to connect with a web network server. This server runs web server software to access and transfer the web pages you request. The website illustrated in Figure 4.2 uses a hypermedia database consisting of web page content described by HTML, Hypertext Markup Language Code, or XML, extensible markup language labels, image files, video files, and audio. The web server software acts as a database management system to manage the transfer of hypermedia files for downloading by the multimedia plugins of your web browser. Data warehouses and data mining. Let us take a look at data warehouses. A data warehouse basically stores data that has been extracted from the various operational, external, and other databases of an organization. It is a central source of the data that have been cleaned, transformed, and cataloged so that they can be used by managers and other business professionals for data mining, online analytical processing, and other forms of business analysis, market research, and decision supports. Data warehouses may be subdivided into data marts, which hold subsets of data from the warehouse that focus on specific aspects of a company, such as a department or a business process. Taking a look at Figure 3, you will see the component of a complete data warehouse system. Notice how data from various operational and external databases are captured, cleaned, and transformed into data that can be better used for analysis. This acquisition process might include activities like consolidating data from several sources, filtering out unwanted data, correcting incorrect data, converting data to new data elements, or aggregating data into new data subsets. These data are then stored in the enterprise data warehouse, from which they can be moved into data mart or to an analytical data store that holds data in a more useful form for certain types of analysis. Metadata, data that define the data in the data warehouse, are stored in a metadata repository and cataloged by a metadata directory. Finally, a variety of analytical software tools can be provided to query, report, mine, and analyze the data for delivery via internet and intranet web systems to business end users. One important characteristic about the data in a data warehouse is that, unlike a typical database in which changes can occur constantly, data in a data warehouse are static, which means that once the data are gathered up, formatted for storage, and stored in the data warehouse, they will never change. This restriction is so that queries can be made on the data to look for complex patterns or historical trends that might otherwise go unnoticed with dynamic data that change constantly as a result of new transactions and updates. Data mining. Data mining is a major use of data warehouse databases and the static data they contain. The data in a data warehouse are analyzed to reveal hidden patterns and trends in historical business activity. This analysis can be used to help managers make decisions about strategic changes in business operations to gain competitive advantages in the marketplace. Figure 4.4 below explains this further. Data mining can discover new correlations, patterns, and trends in vast amounts of business data, frequently several terabytes of data stored in data warehouses. Data mining software uses advanced pattern recognition algorithms as well as a variety of mathematical and statistical techniques so sift through mountains of data to extract previously unknown strategic business information. For example, many companies use data mining to 1. Perform market basket analysis to identify new product bundles. 2. Find root causes of quality or manufacturing problems. 3. Prevent customer attrition and acquire new customers. 4. Cross-sell to existing customers. 5. Profile customers with more accuracy. Study section summary. In this study section, you have learned 1. The need for data resource management, and 2. The types of databases and their uses, and 3. Data mining. This is the end of study section 4. Thanks for listening.